Okay, day 56, here we go. What does it look like? Yep, 1, 2, 3, 4, 5. Good, 5,600. Okay, fraction over 100. 56 over 100. Is that in simplest form? Because they're both even numbers, so both can be divided by 2. So 56 divided by 2, find out. 28 and 100 divided by 2. Oh, is that in simplest form? Oh, they're still both even, so we didn't find the greatest common factor, did we? Okay, what can they both be divided by? 2 again. 28 divided by 2 is, and 50 divided by 2 is 25. Okay, is that in simplest form? Okay, what are the factors of 25? No, not multiples, factors. 1 and 25, 5 and 5, so 5. Can 1, 5, or 25, can 14 be divided by that? Nope, so we know it's in simplest form. Okay, decimal. Good, percent. Odd or even, so I can automatically circle. Decimal in word form. Good. Day in expanded form, what's the value of the 5? What's the value of the 6? Equals? Good. Okay, factors, 1 and 56, 2. Because it's an even number. 3, what's 5 plus 6? Oh, because there's something times 3 that gives us 11? Nope, 4. Ooh, true. Let's think about it. Because look at right here. We divided by 2, we divided by 2. So what did we really divide by? 4. 4 and 14. Good. 5. Doesn't end in a 5 or 0. 6. Doesn't have 2 and 3 as its factors. Good. 7. Oh, what is it? 7 and 8. So are we done? Yes, because we hit that 8 right there. Okay, 1 to 56, 2 to 28, 4 to 14, 7 to 8. All right. Uh-oh, where's my... Where did my daily number go? Just like that, I told you to get all prepared with math stuff, and I am not prepared. Is it back there? Right here? It is. No, it's over here. Okay, week 12 Wednesday, right? Right, 6/10 divided by 12/10. So what is the group that's going to be divided into groups? 6/10 is our group that's going to be divided, right? It's going to be divvied out to everything. Okay, how do I do 6/10 then? Okay, and then I'm making groups of what? 12 hundredths. Good. Can I make one group of 12 hundredths? Yep, right there. There's one. Now I need to make another group of 12 hundredths. So I have 8, 9, 10, 11, 12. There's another group of 12 hundredths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's another group of 12 hundredths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's another group of 1200s. And one last group of 1200s. Okay, so 6/10 divided by 1200s is 5. We took 600s, we divided it into groups of 1200s, and we got 5 groups of 1200s. Okay, 3/4 times 1/3. What are we going to do? Yep, split it into fourths first. Good. How many of those are we going to color in? 3 of them. Okay, then what are we going to split it into? Oops, I'm going ahead of you. What am I going to split it into? Thirds. How many of those am I going to color in? 1 of them. Okay, so what's our whole cut into now? Well, it's good. And how many have the 2 colors the same? 3. Now, is that in simplest form? Oh, yep. Our first question is, can 12 be divided by 3? Can it? Yep. So 3 divided by 3 is? 12 divided by 3 is? So there is our simplest form. Okay, what is the volume? Well, what is the base here? 1, 2, 3, 4, 5. 1, 2, 3. So our base is what? 15. Good. Well, we have another base right here, but we've already counted these 3 on the bottom in the base, right? So we just need to count these. How many? 6. So 15 plus 6 equals 21. Good. 21 cubic units. Okay, round to the nearest. What place value is my 1 in? The tenths. Which number is in the tenths place? The 8 is in the tenths place. Who's going to tell the 8 to do something? The 0. The 0 is going to tell the 8 to stay the same. Numbers to the left stays the same. And then because we're doing decimals, we're not going to make zeros their names. That's only in whole numbers. Okay, what's this one? Place value. Hundredths. Whose number's in the hundredths place value? The 0. Who's going to tell the 0 to do something? The 9. The 9's going to tell the 0 to go up. Numbers to the left stay the same. Okay, what place value is this one in? Thousandths. Which number's in the thousandths place? The 9. Oh dear. Okay, so who's going to tell the 9 to do something? The 6 is going to tell the 9 to raise the score, right? So then he becomes a 10. So what does this one become? A 1. Numbers to the left stay the same. Now, why did I put that 0 there? Oh, go ahead, really loud. Okay, and why else? Because I could say, oh, well, that's a 0 there. And Mrs. Johnson said I have to put a 0 there or 0 there. Why did I put a 0 there? Riley? No, sort of, no. What did it ask us to round to? Not the nearest tenths. The thousandths. So I need to go out to the thousandths place value. That is why I put a 0 there. Okay. All right. We're multiplying by 10. So is our number going to get larger or smaller? Larger. Well, look at this. We already have a decimal in there. So what is this 10 going to tell us to do with this decimal? Move it, right? Because every time I move it one place value, what am I doing? Multiplying by 10. So if I'm going to multiply by 10, how am I going to move my place, my decimal? 1 to the right. Good. How many times am I going to move my decimal? Twice. What do I do in that space? Add a 0. Annex a 0. How many times? 3 times. And in those two spaces, okay, now I'm multiplying by a decimal. This is like when we find 80% of our score. Okay. So what am I going to do? Okay. So remember, when I do by 8/10, what do I count? What do I count? How do I know how many times I'm moving? How many numbers are behind the decimal? How many are behind the decimal? Once. Which way is my decimal going? To the left this time. Yep. Because I'm multiplying by smaller pieces. Okay. How many times? Twice. How many times? 3 times. What goes in that space? A 0. Okay, I'm going to change up things a little bit. At this point, we usually correct. I don't want to take the time on the video to correct, so we're just going to move right into our math lessons, and then we will correct after that, okay? Okay, so I want you to open up to page, I had it open, but then I closed it. $167. Hey, applying properties of addition. Who'd like to read what I can do today? Really loud, ready? Okay, so I can apply the properties of addition to add fractions and mix numbers. Hey, there's a couple words that we need to talk about before we get going. Sure I'm writing this. All right. Okay, we've been in language arts, we've been talking about root words, right? Latin and Greek words that help us define what things are, right? Okay. So in the commutative property, what base word do you see there? Commute. Does anyone know what it means to commute? Yes. Okay, so communicate, the com would be our Latin or Greek root. Okay. How many of your parents have said, my commute to work is this long? Okay. Usually when someone commutes to work, they're traveling to work. So that's not saying, okay, my commute is, well, I do have a commute that's 2 minutes to school. But a lot of times when they talk about commute, it's like people that work up north and they have to commute for an hour and a half to get to work, okay? So knowing that, what do you think commute means? To what? To travel. Okay, to travel. What about, I know there's a commuter train. You ever heard of a commuter train? Okay, means it moves people, okay? So commute means to move, okay? So if you understand that, the commute means to move, what do you think is going to happen in the commutative property of addition? The numbers can move, right? Okay, so let's talk about if I did 3 plus 4 plus 5. What does that equal? Okay, 12. What would 5 plus 3 plus 4 equal? Oh. What would 4 plus 5 plus 3 equal? Why? Yes. Okay, so they're all the same numbers. All we're doing is what? Moving them around. What does commute mean? To move. So what do you think the commutative property of addition, tells us? Come on. Sometimes I have to hide. Hold on. What do you think the commutative property tells us then? Okay, we can move our numbers around when we're adding, and the answer will still be the same, right? It's not going to change our answer if we say you have to be first when we're adding. Yes. Okay, with multiplication, you can. With division, you can't. With subtraction, you can't. So we have the commutative property of addition, and we have the commutative property of multiplication. Okay? So commutative property, we can switch everything around when we're adding. It's not going to change the answer. Okay, associative. What's our root word? Associate. Okay? What does it mean to associate? Yes. What do you think? Okay, to talk to someone. What else? Anything else? Okay, right now we're told that we shouldn't associate in groups larger than 10, right? So it means we can, what does associate mean? Together, right? Okay, so the associative property means we can put parentheses around. There we go, back to our 3 plus 4 plus 5. If I put that there, what do I do first? Yep, equals plus 5 equals 12, right? Okay. Okay, so what, oh dear. Nope, it is. I know, but yeah, I would. Okay, so those are the two things that we're going to work with today. Okay? All right, let's step it out on page 167. As Priya plays a computer game, the experience bar fills to show her experience level. The bar fills to 1/5 before completing a level. After completing the level, the bar fills another 3/5. As a bonus, it fills an additional 1/10. What is her experience level now? It says write an addition expression to model the situation. What would be our expression? Okay, 1/5, maybe, plus 3/5 plus 1/10. Okay, so associative, remember, means for grouping. We have to be in groups larger than 10. We can associate with groups larger than 10. Okay? So, based on the expression you wrote in part A, how can you tell the commutative property of addition, the associative property of addition, or both properties to help you find the answer, the sum? What do you think? Remember, commutative tells us we're just going to move them around. Associative says we can group them in different groups and still have the same answer, as long as it's the associative property of addition, right? So let me give you a hint. When you see those, you know we're dealing with what? Associative. Okay? Okay, so you can use the associative property of addition to group the fractions. Okay, so in our order of operations, what did it tell us to do first? What are we supposed to do first in order of operations when there's parentheses? Yeah, do the parentheses first. Now, the associative property tells me that I can group how I want. Would I want to figure out 3/5 plus 1/10 first? Or would it be easier to figure out 1/5 plus 3/5 first? Why?
Because they're both fifths.
Oh, they're both fifths, so we don't have to do what? Find a common denominator. So I want to do this first and then do that. Does that make my problem a little easier to complete? Yes, because now I can automatically say, okay, what's 1/5 plus 3/5? 4/5. So now I have 4/5 plus 1/10. Now what do I have to do? Yep, and I'm going to put it in a column so that it's easier for me. Okay, find a common denominator. What's our first question we ask? Brady? Okay, can 10 be divided by 5?
Yes.
The answer yes, so then our common denominator is what? 10. Good. Okay, when the denominators are the same, the numerator is the same. How do I go from 5 to 10? Awesome. Okay, 4 times 2 is 8. Now can I add them?
Yes.
Okay. 8/10 plus 1/10 is? Well, how do I know that's in simplest form? David. The numerator is 1 less than the denominator. Good. Let's go back and find out what we needed to find out. What does it say? What is Priya's experiment level now? 9/10. It's a word problem, so what do we need? Of the bar or level would work. Yeah. Okay, good. Flip the page. This one just gives you a problem. It says add 1 5/9 plus 3 5/6 plus 1 2/9. Okay. It says use the commutative property of addition to put the fractions with the same denominator next to each other. So our commutative property tells us we can do what? What does commute mean? To move. So I can move these around. Where did that come from? We will get this. Oh, it's because of this. Watch. On. Oh, forget it. Okay. So we can move them around to put the same numbers with the same denominator. So how will I move those around? 1 plus 5/9 plus 1 2/9 plus 3 5/6. Good. Okay, what do I want to add first? 1 5/9 plus 1 2/9. What do I do first? Add the fractional parts, right? Okay, what's 5/9 plus 2/9? 7/9. Oh, good. We don't have to regroup. How do I know that's in simple? Well, we won't go there. Okay, then what? Yes, 1 plus 1 equals 2. So now we have 2 7/9 plus 3 5/6, right? Yes. Now let's see. No, it is not. Yeah. Okay, so now we have 2 7/9 plus 3 5/6. Okay, we have to find a common denominator. What's our first question we ask? Can 9 be divided by 6? Can it? No. So we can't use 9 as our common denominator. So what do we need to do? Okay, list the multiples. So multiples of 6. Okay, remember, stop there. Okay, multiples of 9. When can I stop? Oh, we got 36 and we have 18. So what's our common denominator? 18. How do I go from 9 to 18? Times 2. What do I go do to the bottom? 7 times 2 is? Hey, how do I go from 6 to 18? What do I do to the bottom? 5 times 3 is? Oh, okay, now what? I am going to have to regroup, but before I have to regroup, what do I need to do? Add, right? Okay, what's 14 plus 15? Good job. So now I have 29/18. Ooh, someone learned something yesterday. We can divide, or we can do what? Yeah, we can take away groups of 18/18, or we can take away the wholes. Which one do you want to do? Oh, he said there's only one that can be taken out. So this is a case where probably just taking out the whole, right, is easier. If it was like 290/18, we would want to divide. Okay, if I take out one whole, what is one whole? 18/18. So what's 21 minus 18? Do we need to do it? Yep, there it is. 9 minus 8 is 1. 2 minus 1 is 1. So we have 11/18. Well, what do I do with this 1 that I took out? Yep, I regroup. It now becomes a whole, right? Okay, 1 plus 2 plus 3. So I get 6 and 11/18. Is 11/18 in simplest form? Yes. Why? 11's prime and yes, you have to answer that question too. If you are going to use the prime answer, you have to say 11's prime and 18 can't be divided by 11. Okay, good. So we got 6 and 11/18. Okay. Now, they want you to work with the commutative property and the associative property, right? They want you to say, hey, take these two, add them together, then add this. But I want to show you what else you can do if you find that this is a lot of work, okay? Could I add all three together? Come on. Oh, there it goes. Yeah. Not necessarily. Let me show you. 3/5 plus 1/2 plus 4/5. What would I have to do? Find a common denominator, right? So this one, where it's this case, this one's pretty easy because it's 7/5. But this is if you have like mixed numbers. So let's do this one using the associative property or the commutative property. What are we going to add? 3/5 plus 4/5, right? Which gives us what? 7/5 plus 1/2. Now we have to find a common denominator, which is what? 10. How do I go from 2 to 10? What I do to the bottom? Okay, 1 times 5. How do I go from 5 to 10? What I do to the bottom? Okay, 7 times 2. Okay, 14 plus 5. So I have 19 tenths. Can I leave it like that?
No.
Okay, I'm going to take out a whole, which is what? 10 tenths. So 19 tenths minus 10 tenths equals 9 tenths. But what do I do with this 1? Yeah, it's got to go over there, right? So what's 1 plus 0 plus 0? 1. So my answer is 1 and 9 tenths. Why do I know that's in simplest form? Numerator's 1 less than denominator. Okay, one more. And then I'm going to let you go. Okay? And I'm going to show you this is probably the case where we could add 3 of them. 1 1/4, 1 2/3, 2 2/3. So which 2 would we add together if we were doing the associative property? Yep, I would do these 2. But I can just do it all together if I wanted, right? I could find a common denominator of 4 and 3, which would be what? 12. Okay, how do I go from 4 to 3? Oh, whoops, 4 to 12. 1 times 3 is, how do I go from 3 to 12? 2 times 4 is, how do I go from 3 to 12? 2 times 4 is, now can I add them all up? Yep, 8 plus 8 is, plus 3 is 19 twelfths. Can I leave it like that? No, I'm going to take out a whole, which is 12 twelfths. So that's my whole. 19 minus 12 is, and what's my denominator? Okay, what do I do with this whole that I took out? Regroup, put it in there. 1 plus 1 plus 1 plus 2. Okay, 5 and 7 twelfths. How do I know that's in simplest form? 7's prime and 12 cannot be divided by 7. Okay, so you can do it either way. You can group it and add those first and then add this at the end. Or you can just add them all together, find a common denominator, find the equivalent fraction, add, regroup, and find your answer. Okay? Okay, fist to 5 on how you're feeling about adding 3 and 4 fractions. Fist to 5 on knowing the difference between associative and commutative properties of addition. Hey, looks like what's your vote? Looks like we have all 4s and 5s. Okay, so we have about 30 minutes. I don't know if we'll be able to do groups real easy. Okay, and I don't know who's in which group and who's not here in which group. Okay, so what we're going to do is we're just going to have both of us walking around trying to help. Okay, instead of doing groups at this point, plus we probably should stay apart on groups. Okay, everybody okay? All right, your assignment then today is practice 7.5 front and back. I want to, if you need graph paper, or you may use just white paper, but I want you to show me your work. Okay?